Chapter 11, where we're going to be talking about arithmetic and using it within your programs. In this video, you'll learn how to compute and set values using math expressions in your code. I'm going to help you get comfy with the order of operations and why this matters when it comes to the calculations in your program. We're going to use built-in math methods to make your expressions smarter and easier. And then ultimately, we're going to write a simple program that adds a bunch of numbers and shows the results. Before we continue with other programming principles, like decisions and looping and such, I want to take a pause and talk about using arithmetic within your programs. You see, there are going to be times when you're going to want to, not just do something like set the value equal to 10 or something like that, but do something that's more complex. And we're not going to talk in this chapter about something that's going to mean that you have to have a PhD in arithmetic to be able to do it. We're going to keep it really simple. In chapter 6, you learned how to set a value of something like this. Well, you're going to learn in this chapter how to write an arithmetic expression that's more like this. Total equals, open parentheses, number 1 plus number 2, close parentheses, divided by, open parentheses, number 3 times number 4, close parentheses. So let's get into it a little bit. So we can't use all the same symbols on a computer that you typically use when you were writing math equations on paper. For example, you used an X to mean multiply, and you used a little line with a dot up above and below it to mean division. But we can't really use that character set with a computer. So a star is what we use for multiplication, and a slash is what we use for division. In fact, here are the common basic set of arithmetic operators. And so you can see the first line we use a plus, the second we use a minus, the third we use an asterisk or a star to mean multiply. Division, we need a slash to mean division. And then we can string a combination of these together with parentheses and whatnot to get the desired result that we're looking for. Before we go much further, I just want to show you some really common things that we see with arithmetic. So the first example here, number 1 equals number 1 plus number 1, plus the value of 1, or another total equals total plus number 1. Let's take a minute and talk about what these mean. So the first one means that we take the value that already exists in the variable number 1, and we add a 1 to it, so we increment it by 1. And then we take the resulting value and we put that back in the variable number 1. For total, we take the value of total at the time, we add whatever the value in the variable number 1 is at the time, and then we take the combination of those, the sum of those, and we put them back into the variable called total. These types of statements we call accumulators. But there are more than just these. Here are some common operations that we see and some examples of them. So we already kind of talked about the first one down in the table below, count equals count plus 1. You can do the same thing but as a decrementer, which would be count equals count minus 1. And then there are two of them here that are a little bit different. Count plus plus means exactly the same thing as count equals count plus 1. And count minus minus means exactly the same thing as count equals count minus 1. We used this one on the previous slide, total equals total plus number. But you could also write that exact same thing as total plus equals number. Just makes it shorter. Sometimes it's a little harder to understand. Or total equals total minus number, and you can write that same thing as total minus equals number. Now I'm going to stick throughout this video series to the most common usages and the ones that are a little bit easier to understand. The next thing that you need to understand about arithmetic operations and equations is the order of operations. You may have learned about this back in math in school, but there are 4 basic rules that you need to make sure you understand. Java comes with a set of math functions or math methods that can calculate things like square root, the power of an exponent, those kinds of things. And Java always calculates those things first in an equation. It then does anything that's within parentheses. It then performs all multiplication and division from left to right, and then last, it performs all addition and subtraction from left to right. Now, why do you have to care about this? Well, The order of operations actually, if you don't follow the order of operations, you'll find that your formulas may not have the results you're looking for. Let's look at an example of this. So if we assume that we have 4 numbers, these are all floats with values 1, 2, 3, and 4, and we write this equation with parentheses, total equals parentheses number 1 plus number 2, parentheses slash parentheses number 3 times number 4 parentheses. If I run that, given the 1, 2, 3, 4 values, then the result of that is a 0.25. But if I take that exact same equation and I just remove the parentheses from it and I run it again, the value of total is 3.666667. Wow, amazing how different the two values are just by removing the parentheses. That's why it's so important to remember the order of operations. So I mentioned that Java comes with its own functions. We call them methods in Java, but they're built in and you can use them directly within your equations. Here are some of them. This is the kind of the top 10. It'll calculate absolute value. It'll collect the smallest of a couple of values, square root. It'll return a random number. We'll use that later. It'll return the max of 2 numbers. It will round to the nearest decimal. It will do power of or exponents, and it'll do logarithms. So, we're not going to mess with all of these in this video series, but certainly you could play around with them. So, like I mentioned, you can use these math methods just directly in your equations. And here's an example of that. So in this equation, notice way over on the right side, we're using the power method. That's the exponent. So this would be power of a number equals parentheses, number 1 plus number 2, close parentheses, times math power 100 comma 2. So what it does is, if you remember from our order of operations, we're going to first calculate the math function. So this would be 100 to the power of 2. And it would calculate that. That's 100 times 100, by the way. And it would take that value and it would store it there. And then it would go and it would look at the thing that's in the parentheses. So number 1 plus number 2. And it would calculate that. And then it would take the 2 and it would multiply them together. And it would take that value and it would put it in the variable power of a number. See how that went? So here in a second, we're going to give you an opportunity to try using the things that you've learned about arithmetic in a real live program. It's time now for us to try what we've learned when it comes to arithmetic equations. For our try exercise today, we have these requirements. First, we're going to ask the user for 2 numbers to input. Then we're going to take those 2 numbers and add them together. And then once we've done that, we're going to calculate the square root of those 2 summed numbers and display the total. The pseudocode will look like this. First, we'll prompt the user to enter a value for number 1, and we'll store that value. Then we'll prompt the user to enter a number for number 2, for variable number 2, and then we will store that variable, the value for that variable. Next, we're going to add the variable number 2 and number 1 together, and then we're going to calculate the square root of those, that's the sum of those 2 numbers, using the math square root function, and store the result of that in a variable called total. And then lastly, we will display the results of total. Now that we understand what the problem is that we're trying to solve, and have a pretty good understanding because of the pseudocode, how it is that we're going to solve it, let's get to the program. All right, so we're going to follow the same process pretty much. We're going to call this program, or this class, my calculator program. Again, no spaces, upper and lowercase, you need to match. Enter. We're using input, so let's put the import up here. And then we'll trudge along just like we have been on many of our other programs. Public, static, void, main, string, args. We'll set up our scanner. All right. Now, we need 3 variables that are numbers. And we're going to use a new variable type, double. A double, if I spell it right, is basically the same thing as a float, except that it allocates twice the space to store the number, thus the name double. And because of that, it can store billions of higher numbers than a float can. Now, we don't really need billions of higher numbers for our example here, but just giving you a chance to use these different types. We're going to create one called number 1, going to create one called number 2, and we're going to create one called total. All right. Now we're going to follow our similar pattern. System out print. We're going to print the label first. Enter number 1. And then we're going to gather input for number 1. Now, just like we've seen on some of the others, because we're using a double, we need to use a different input method called, next, you guessed it, double. Can't get anything by you, can we? Then we're going to do the same thing again. Enter, gotta spell it right. Number 2. All right. And we'll fill number 2 from input. Got it? All right. So everything's kind of similar to what we've done in the past. Now, we're going to use a math function as a part of our calculation of total. So it's not going to look a lot different. Total equals, we're going to say math dot square, SQRT, that's for square root. And notice that when it gives us the definition here, it says it needs to be a double. That's the reason why we're using a double, because it needs to be a double. Now, inside of the parentheses here, we're actually going to do our addition of number 1 and number 2. Now, we could have done it using and stored it in a separate variable, and that would have been okay too, but this just makes it a little bit cleaner. Number 1 plus number 2. Now, since we've talked about how the order of operations works, the stuff inside of parentheses gets executed first. So what's going to happen when the computer is running this line is it's going to take the variable value for number 1 and then take the variable value for number 2 and add them together and then take the result of that and then execute this math function. Now again, the reason why we didn't have to add an import up the top for math is because this math function or class is a part of the built-in kind of basic features of Java. All right, now the last thing we want to do is output. System out print line the total all right, now we could have said something like, we could have also done something like this. The total of number 1 plus number 2 is, oops, gotta have a plus right there. Something like that. And that would be okay too, but just wanted to keep it simple. So that's the reason why we did it this way. You, when you're looking at more things you can do to learn, can do exactly what I did there. I gave you a little hint about that. All right. Scan your application program, make sure that it looks like it's running well, like you've got it written down right. You don't have any red underlines or such. And now let's run this baby. Okay, we're going to go down to run. Dun, dun, dun. Waiting for the results here. All right, it's going to ask us. All right, so we can do anything we want here. 10.5, 20.5, 9. Now look at how it automatically calculates the square root here. 5. Now look at how many numbers there are behind that thing. In some future chapters, we'll give you a little bit more information on how to make this a little bit more presentable so that you don't have to have 10 digits after the 10 numbers after the digit, after the decimal point. But as it is, it's giving you a very accurate computation of 10.5 plus 20.9, the square root of that. So hope this will help you to better learn how we work with arithmetic expressions. Here are some more activities that you can try to learn even more about this topic.